Okay, so this video goes with the notes for shape properties, rectangles, rhombuses or rhombi, and squares. So definition of a rectangle: all four angles are right angles. Actually, one right angle is enough to make a rectangle, to force the parallelogram into a rectangle. If you have opposite parallel sides and you have one right angle by same side interior, you have another right angle. Then by parallelogram, you can know opposite angles are congruent, jumps a right angle over there, and opposite angles are congruent. So one right angle, supplementary, same side interior, and then opposite angles, or you could do same side interior, supplementary, stuff like that. But one, at minimum, one angle in a parallelogram, all the angles are going to be right angles. Opposite sides are parallel and congruent, just like in a parallelogram. Diagonals bisect each other, just like in a parallelogram, except in a rectangle, rhombuses, or the diagonals are going to be congruent to each other. In some parallelograms, might not be the case. Let me make a parallelogram like this. So here we have a shorter diagonal and a longer diagonal in that parallelogram. So, but in a rectangle, diagonals are congruent. Because it's a parallelogram, they bisect each other. Because it's a parallelogram, opposite sides are parallel and congruent. And because it's a rectangle, it has a right angle. Okay, so let's look at these examples. Coach Conroy is making the basketball team run drills along the diagonals of the court, as shown. If F to C is 106 feet, so if this distance here is 106, it's asking us find DG. D to G is this part right here. Now, because this is a rectangle, the diagonals bisect each other. The diagonals are congruent. So each one of these sections is going to be half 106, which is 53. So from G to D is going to be 53 in its feet. Looking at number 2, they're telling us that S to T, this diagonal here, or this half this diagonal is 21. That means the other half must be 21 because the diagonals are bisected. This one's going to be a 21. This one's going to be a 21. And it's asking us what's the distance T to Q. T to Q is going to be 21. P to R is going to be 42. And this is inches. Let's move up. Okay, quadrilateral MNOP is a rectangle. So they don't give us a diagram unless this is it here. A, B, C, D, P. I'm taking it that these two go with this diagram and this one goes with this diagram, because here they don't really tell us anything about it being a rectangle, which is what this is all about. So I'm thinking these two go together. So that's how I'm going to solve these. So number 3, quadrilateral MNOP is a rectangle. If MO is 2x plus 6, so we got 2x plus 6 for this long distance here, and N to P is 6x minus 15, find the length of NP. So in this rectangle, the diagonal MO is going to be congruent to the diagonal NP. So we can set 2x plus 6 equal to 6x minus 15. Okay, combining like terms, take 6x away from both sides. We have minus 4x's plus 6 equals negative 15. Take away 6 from both sides. We have negative 4x's equals negative 21. Divide by negative 4. X equals 21 over 4, which is 5.25, 5 1/4, 5 1/4. That's x. Now, once it's defined the length of NP. NP is 6 times x, take away 15. So if we use x as 21/4 to find NP, we have 6 times 21/4, which is the 5 1/4, minus 15. So I can simplify. 2 goes into 4 twice, 2 goes into 6 3 times. So basically we have 3 times 21, which is 63 divided by 2, minus 15. Go for common denominators. 30 over 2 is the same as 15. So we have 63 over 2 minus 30 over 2, which gives us 33 over 2. And 33 over 2 is the same as 16 and a half. So the length of NP is 16 and a half. And they don't give us units, or feet. I guess no, they don't give us units. Yeah, let's go ahead and do number 4 while we're at it. So if the measure of angle NOP, this angle here, is 2y minus 3, and the measure of MOP, M to O to P, this angle here, is y plus 12, find the measure of MOP. MOP. Okay, so let's see what we got. 2y minus 3, if this is a rectangle, like they're telling us up here, then this is a 90-degree angle. And they're also telling us that 2y minus 3 is the same thing as this 90-degree angle. So 2y minus 3 equals 90. Add 3 to both sides. 2y's is 93. Y is going to be 93 over 2, which is like 46 and a half. So that's what y is. Now he wants to find the measure of MOP, M to O to P. Now MOP is given as y plus 12. So if we take 46 and a half and add 12, we get 58 and a half. So that's going to be the measure of angle in MOP. Is 58 and a half. So we had to use the idea that because it's a rectangle, got a right angle, they gave us another way of expressing the right angle so we could solve for y. And once we got that, we could plug it into the equation for MOP, angle MOP, and find out what its measure was. Okay, let's look at number 5. Quadrilateral ABCD is a rectangle. That means, again, we have right angles and diagonals bisect and everything like that. If BAC, if this angle here is 3x plus 3, and ACB, A to C to B, and this angle here is 5x minus 1, they want us to find x. So let's see what we got going on here. Opposite sides of a rectangle are parallel. So if we kind of look at AB and DC as being a pair of parallel lines, then this AC diagonal is a transversal, and this angle BAC is an alternate interior angle with angle DCA, which means they need to have the same measure. So 3x plus 3 is also the measure of this angle down here at the bottom. And then together, these two angles at C need to add up to 90 degrees. So we have 3x plus 3 plus 5x minus 1 equals 90. Combining like terms, we have 8 x's. We've got a 3 with a minus 1, which is a plus 2, equals 90. 8 x's equals 88. X equals 11. And for this one, all he wants to do is find x, so we're good with that. Let's move on. Now, rhombus is defined as a parallelogram with all 4 sides congruent. So opposite sides are parallel, all sides are congruent, and notice with the diagonals that the diagonals bisect each other. The diagonals bisect because it's a parallelogram, but because it's a rhombus, the diagonals are perpendicular bisectors of each other, and they form a right angle when the diagonals intersect. So each diagonal bisects a pair of opposite angles. And that's the other thing about rhombuses. Diagonals bisect the angles, and the diagonals are perpendicular, and then because it's a parallelogram, we have the diagonals being bisectors of each other. So all that goes with a rhombus. So just look, see what else we got. So it's telling us here for number 6 that LM is 2x minus 9. It means all the sides are 2x minus 9. KN, K to N, which is this length here, is x plus 15. And these are all going to be congruent with each other because it's a rhombus. And it wants us to find the value of x. So actually we can set these two expressions equal to each other and then solve for x. So we have 2x minus 9 equals x plus 15. So if we add 9 to both sides and take away x, we get x equals 24. And they just want us to find the value of x. So x is 24. So look at number 7. Again, with this same diagram, excuse me, the diagonals intersect at P if angle LMN, L to M to N, this angle here is 75 degrees. We mark that. So this angle here is 75 degrees, LMN. Find the measure of KNP. KNP is this angle here, and they want us to find that angle. So if this is 75 degrees, this opposite angle is going to be 75 degrees because of it being a parallelogram. This angle at N, this angle KNM, the big angle, is going to be supplementary with 75 because they're same side interior angles with the parallel lines. So 180 take away 75 is 105. So this whole angle is 105. So this whole angle here is 105 degrees because it needs to be supplementary with the 75. So let's see what we can do. So the diagonals bisect. So each one of these angles is going to be half of 75, 37 and a half. This is going to be 37 and a half, 37 and a half. This is going to be 37 and a half. And this is going to be 37 and a half. So we really, without doing any math, the diagonals bisect the vertex angles. This is a 75, this is a 75, this is 105. Okay, KNP, K to N to P is going to be half of 105. So we got 105 over 2, which is the same thing as 52 and a half. So that's going to be the, in degrees, that's going to be the measure of angle LMN, or KNP rather. So look at number 8. This quadrilateral is a rhombus. That means all the stuff with rhombuses are true. All the sides are congruent. Opposite sides are parallel. Diagonals are perpendicular bisectors of each other. And opposite angles are bisected. And these opposite angles are congruent, so that makes all 4 of those the same. And this angle, and this angle, and that angle, and that angle are all congruent because this D and F are also bisected by that other diagonal. So I kind of got it marked up. Let's see what's going on. So if DEF is 78, D to E to F, this is a 78-degree angle right here. Find GFR. GFR is this angle right here. So planning-wise, the angle at E and the angle at F are same side interior angles. They're going to be supplementary. So I can find out what this big angle is at F. And then half of that is the angle we're looking for because we're looking for GFR, which is made by the diagonals. That's going to be the bisector of that angle. So basically 180 take away 78 is 102. This is a 102-degree angle. Half of 102 is 51 degrees. So GFR is 51 degrees. Let's look at the next one on here. If E to F is, let me change colors, is 3x minus 2, and D to G, or DG, is x plus 10, they want us to find the length of DG. Now, in a rhombus, all the sides are congruent, so we can actually set these two expressions equal to each other. We have x plus 10 equals 3x minus 2. Take 3x away from both sides, minus 2 x's, and take 10 away from both sides, equals minus 12. Divide by negative 2, x equals 6. Now, if x is equal to 6, dg is x plus 10. The length of dg is going to be 16. So we got that one. Let's look at the next one. Change colors up. If g to r is 2x plus 12, and re is 4x minus 10, they want us to find out the length of GE. So since these diagonals are perpendicular bisectors of each other, I know that 4x minus 10 is going to be equal to 2x plus 12. So I can set those equal to each other and solve for x. So take away 10 from both, or add 10 to both sides, we get 22. Take away 2x from both sides, we get 2x. We got, did I do the minus 10? Yeah, add 10 to both sides. And then divide by 2, or yeah, x is going to be 11. So we got x is 11. Now they want us to know the length of GE. GE is actually twice each one of these. If one of them is 4x minus 10, we have 44, take away 10, which is 34, or 22 plus 12, which is 34. But this whole length is going to be twice 34. It's going to be 78, I think. GE. Yeah, G to E, the whole length is going to be both of those. So it's going to be 78. See if I did that right. 2 times 11 is 22. That makes 33. And 44 take away 10 is 34. Something's a little bit messed up with some of these numbers. 30. Let's see. 2x plus 12. Let me double check what I found out for x here. Set these equal to each other. 4x minus 10 equals 2x plus 12. Take 2x away from both sides. Add 10 to both sides. 2x's is 22. X is 11. 44 take away 10 is 34. And 22 plus 12 is 33. So they're off by just a little bit there. So we got a 33 and a 34. So together those would add to 77. So 77 or 78. This isn't the best worded question, but I got 78 for the answer. I can see if you did each part, plugging it in, you might get 77. I think 78 is probably the best answer there. Okay, now we're going to talk about squares. Squares are parallelograms. So that means opposite sides are parallel, opposite sides are congruent, opposite angles are congruent, diagonals bisect each other. That all comes from it being a square. In addition, a square is a rhombus, and a rhombus has all congruent sides, and the diagonals are perpendicular bisectors of each other. So that's the additional information. And there's a 90-degree angle then at each one of the vertices. So, and then also in a rhombus, the diagonals actually bisect the angles that they're coming from. And rectangles and other quadrilaterals, they don't. So the angle's going to be bisected because it's a rhombus. And you can see all its properties summarized there. So let's look at number 9. EFGH is a square. If F to J is 19, find F to H. If this is 19 halfway, then another 19 is going to be the rest of the distance. Totally, it's going to give me 38. So the length of F to N, or F to H, is 38. Let's look at number 10. Okay, they're giving some dimensions on this square, so I want to go ahead and label it. So BC, B to C is 2x plus 5. FD is 47. F to D is 47. So we got a way to find out what x is at least. And GD is x plus 12.25. So G to D is x plus 12.25. And wants us to find each measure. So find out what BC is. Now, if this is a square is a rhombus, all the sides are congruent. So this is going to be 47. The length of BC is 47. CD is also going to be 47. GD, G to D, is going to be half the length of the diagonal, which is x plus 12.25. What else have we got? We haven't got any other information about the diagonal there. So totally this diagonal is 25. But we just want the GE part, which is x plus 12.25. So let's go back up like we're doing number 1 and find out what x is. So these BC and FD are congruent to each other, so we can find x out of that. We've got 2x plus 5 equals 47. Take 5x away. 2x's equals 42. X is going to be 21. So we got x is 21. To find out what the measure of GD is, it's x plus 12.25. If x is 21, 21 plus 12.25 is going to be 33.25. So that's the answer for GD. Now BD is going to be twice that. So, and they're all the same, so I could really do 21 plus 12.25, which is 33.25. And do that times 2, because that's just half the diagonal, and we get 66.5. So the length of that whole diagonal is 66.5.